Welcome, everyone, and thanks for joining another Silicon Labs product podcast. Today, I'm really excited. I have the guys from Firia with us. If you don't know who they were, you probably didn't attend WorksWith. This episode is going to cover some of the content that Firia covered in their courses. I'm joined by Donnie. You're a design engineer at Firia, correct?
Yep, that's correct.
And David, you're, as you coined, the El Presidente of Firia.
See, howdy.
So thanks, guys, for joining. As I said, you covered two courses at WorksWith. One was the how to build a gateway, and the other one was how to go from chip to cloud or device to cloud. So I'm going to separate those conversations into two podcasts, two episodes. So I invite our listeners to look for the other one. This one, we're going to focus on your course that covered how to design a gateway. So are you guys ready to go?
Yeah, let's do it.
All right. I'm going to ask some questions. As I mentioned, this is probably going to be the crib notes version. I strongly suggest everyone see your full length course. I put it in the details of the episode so people can quickly go and see the full glory of your education content. But let's get started. For the how to design a gateway, in your course, you talked about some of the primary reasons that customers need to include a gateway in their product solution. Can you touch on some of those reasons?
Right. Yeah. One of the things we talk about is that gateways are a necessary evil. So if we talk about connected products, a lot of times people don't think about, is it going to require, a box that sits over in the networking closet somewhere, or in a residential application, it's wherever your Wi-Fi router is, and those aren't a part of the system that you oftentimes think about first. And sometimes you can get away without having a gateway. So if it's a directly connected, Wi-Fi module embedded in something, then you don't need a gateway necessarily. You might just be hitting the cloud directly from those devices. So we kind of get into some of the reasons why, even in those applications, you may want to, based on maybe you need to aggregate some data, you have some latency requirements that, you want to see stuff quickly. So stuff that you might want to do processing at the edge, that a gateway is good for. And then of course, applications where you've got, a mesh, whether it's OpenThread or BLE or, or some proprietary protocol, some other system that you're wanting to kind of bridge onto the internet. Well, in those cases, those are kind of classical gateway cases, right? You really have to have some device that sort of translates from whatever the non-IP connected protocol is over to the interwebs. And in thread land, it's a border router, right? So it's one of the functions a gateway would perform, right? Is to do that. But we kind of compare, going through what do those things look like in a consumer environment, and what might they look like also like in industrial, environments and commercial environments too.
Yeah, and what can you get away with, just on the device itself versus having a gateway, because they can cross over some of their functionality. So you definitely do have to weigh the pros versus cons of actually having, it's an extra device that you got to have.
Yeah.
But
you'd rather not have one.
Yeah, you'd rather
man,
not.
I don't want that. It's like, but also there's another aspect to it. So the gateway faces off to the cloud. So depending on what cloud you're using, are you using Azure, are you using Google Cloud Platform, AWS, or something else, you've got to think about, well, how does the gateway interact with the cloud? And do I have, security is a big element there. How much security do I need? And what does the cloud require of me? If I'm going to develop an application on this, do I need to be able to deploy it, remotely from the cloud down to the gateway? Is there going to be functionality like that happens?
Yeah, how about updating the devices remotely?
Yeah. So anyway, so there's a lot into that.
Well, so why don't you go to the next step? And in your course, you gave a lot of great case studies. Maybe share one or two actual case studies where you've solved those needs of the customers for a gateway.
Yeah. So specifically, in some applications, you'll have customers that need something special from their gateway. So we mentioned one that was for a company called Dark Energy that has an asset tracking system. And it's special in a lot of ways, and it's different than normal asset tracking systems out there. It's not concerned with precise location of the devices, but they needed really, really high reliability, 5 nines reliability of knowing that the asset is in a warehouse or not. So it's like zone-based location. And it could be in a yard, or it could be in an inside warehouse or something. So what they needed wouldn't really, we had to have some proprietary protocols to be able to do the sort of the long range detection, and also to manage the energy consumption of these tags. So the asset tags had to last on coin cells, they had to last, more than 5 years, and they had to be really cheap. And so this is a Series 1 based, chipset that we used in that. They're going to BG22 but it was, so it's proprietary 2.4 gig. So the gateways in this case were also, they were not just connecting onto, like it was a PoE backhaul. They wanted power over Ethernet. They wanted to put lots of gateways out that could, each gateway could broadcast beacons, basically, that whenever a tag woke up, it didn't have to stay awake long at all before it could immediately, get its information, go back to sleep, report in. So you wound up with a requirement to have, multiple radios in each gateway, and to have directional antennas in them as well. So there were several things that made it, special in terms of you couldn't really use an off-the-shelf gateway. But then there were some things that we did, that were common with a lot of other gateways we built, like using a Raspberry Pi compute module. It's an awesome way to, kind of leverage a lot of existing software infrastructure. It's not expensive, and we could build this. Had a lot of reliability kind of built into the design from the ground up, going with that. And in that instance, we used, there was tons of Scilab stuff in there, like all the PoE chipsets and things like that. That was all, great stuff that we were able to use off of Silicon Labs products. So it was really neat. Let's see, what's some other ones gateway wise?
Well, I will just say, for the dark energy asset tracker, like that one, right from the get-go, just the size constraint dictated the battery constraint, which just negated the idea of doing all of this directly on the device itself. So like we knew we were going to have, some sort of gateway, regardless in this application.
And this one, there's a lot. Like so it depends on how large it is. So if you have say a 200,000 square foot warehouse, there's a lot of these devices. So it's not just to get me onto the internet, but it's sort of translate from the device regime onto a TCP/IP regime. And then there's another box in this application. There's going to be like a site aggregation box, which could be a gateway itself, or could be a server that then takes all the sort of deduplicates the data that's streaming across that Ethernet link, and then connects off to the cloud. And now you have inventory management and all the other applications that you want to do with it. So there's a couple of levels there. Another application we've done, the gateway was special. It needed, again, some different radio connectivity pieces that were not available in off-the-shelf gateways. So there's a gateway that we did for a healthcare application that needed a LoRa, radio socket, and had a cell modem, and they wanted to use a particular, Quectel cell modem. And there's just requirements that made us go down that road. But those kind of drove to our design of the XG1, which was, we kind of got tired of making special gateways for every customer. We wanted something we wanted to build something kind of, and since Firia is a consultancy, we were building these things kind of bespoke artisan craft gateways for different customers. Like, hey, let's just go off and make one that we think will solve a lot of these issues and have enough expandability so that the next customer that comes along, we actually already had a couple of customers in mind that would be able to use this right out of the gate. And we had, some sockets that we could have some leeway to build it how we wanted to. But all those kind of fed into those design decisions on the XG1.
Yeah, and once you kind of design a couple of them, you start to see the crossovers of for these type of applications. They're typically going to use A, B, and C, and it did just get monotonous of like designing the same type of gateways over and over again, with little changes. So the XG1 was it was kind of a no-brainer for us after doing a couple of these.
Yeah, the overview you guys gave in the course is great. Specifically for a Silicon Labs person, as you mentioned, you had the Red Pine for the dual band Wi-Fi and BLE as well, and then you had the I believe the MG device on there. Can you talk a little bit about the selection of those and high level what they add to that gateway for, as you said, all these different gateway applications where they may see this XG1 as being a great solution for them?
So yeah, so we went into it, and we've had a great partnership with Silicon Labs with a number of they've brought a number of our clients to us, and we're trying to obviously delight all of our clients and make all of us look good and sell a lot of products and make applications get out into the world that are gonna be successful, because we're all successful when they thrive. So we went into it knowing, we've already used a lot of these parts, the Scilabs modules of different flavors. It was right about the time that the Red Pine acquisition was going on. So, and in fact, I didn't realize Red Pine had a module that was really appropriate for this. We were actually going down the path of looking at we knew we wanted an SDIO, high-speed interface to a Wi-Fi module. We knew we needed dual band because we wanted to have 5 gigahertz, because a lot of our applications are 2.4 gig. We also have sub-gig applications. that we work. But we knew it would be really great to have that separation of having a 5 gig kind of Wi-Fi backhaul in some of these applications. So that was a requirement. And we were looking at some, I guess it's Murata modules actually that kind of had the same Cypress, Broadcom, whatever the chipset is, that the Raspberry Pi, if you get like a Raspberry Pi regular device, not the compute module,
that's what they got.
That's what they're using, right? So we're like, yeah, let's look at that. And even the early on design support we got from those guys was really terrible. So not to say anything bad about a competitor or anything, but they're just not great. And maybe it's because we were, we're small, and so it didn't matter to them. But as soon as I saw that Red Pine actually had, that got me looking. I saw that Red Pine had this and had a line, and including the RS9116 that we ultimately chose. Reached out, and I'll tell you, we've had nothing but great experiences with the support from Red Pine. They are both, they get the team in India has been super responsive. We can usually next day, if we ask something in the afternoon, the next morning we're on the call with these guys, and they'll help out a lot. So that's been really great, as has of course the support from Silicon Labs. So and now as a team, they all now have Scilab's email addresses. So it's happened, the Red Pine team. So it was a great module. I love that it is applicable to, it has a standalone mode. I think there's one mode called Wise Connect, and then there's a host mode. So you can actually use that same exact module, in an embedded, IoT application. Sort of like you would do we've used the WGM16P in applications. Well, the Red Pine module can be also used. I'm sure it's not implemented, or it's not Simplicity Studio integrated yet and all that stuff. So it's got its own development environment. So there's some work to be done there, but we liked that about it. And we liked the performance and the capabilities of that part, and pricing was good as well. So it was a really great fit, and made us really happy to be able to design that in and then have a even more wholesome Silicon Labs design. The fact that it has BLE also, that's cool. Some of the other modules that we looked at, the BLE part of it was kind of an adder, and it didn't operate over that same SDIO interface. So you had to have a UART running to the module as well as so UART for BLE, and then an SDIO interface for the or USB for the Wi-Fi part.
Yeah, and the configurations you can run that Red Pine in, using BLE and like the standalone AP mode, that kind of gave us options for, commissioning the gateway itself, the XG1, when you buy it. So we can like always run BLE and maybe have it in an AP mode, where it's an access point, or have it, or, you can set it up so it can connect to your existing network and still run BLE right alongside it. So that was a really nice option too to have.
Yeah. And BLE, and what I was going to say earlier is BLE and Wi-Fi run all over that same SDIO interface. Yeah. So you just need one interface out to the part. So it's cool. It was a neat part. Yeah.
And you mentioned the drivers was a great find, where they had the Raspberry Pi as one of their example, code. I mean, you said that with multiple suppliers, but that's a real benefit, is when you work with a supplier and then they have that Raspberry Pi out of the box drivers.
Quick to get up and going with it. Yeah.
A lot more easy to integrate. So before we end, one more question. I know on there you did use the MG, and it was used more for, as you mentioned, the 2.4 proprietary. I like the fact that you mentioned in the course that you called it the ECO, or the ECO processor. Can you talk, just give the listeners a reason to go and listen to the full course? I thought that was a great addition to the XG1.
Yeah, the MG, obviously, as you said, other protocols, and I guess nowadays not necessarily proprietary because it is a module, so there's a limitation there. But things like OpenThread, Zigbee, and other protocols that you can run with that MG, in our case, MG M12P that we're using. Another one that an early application that we had was WirePass. So we were, can use this as a WirePass gateway. So if you have anybody that's a WirePass customer, I think we're like maybe the only Scilabs-based WirePass gateway that's out there. So that was an early application of it. But one of the applications we've seen, and the reason we call it an ECO processor, is applications where you need to be running like on a solar panel, and someone be able to shut down and save power. And a lot of the gateways really don't have internal capability to do that. So we've built that externally on a number of applications where you can, from Linux, you can say, hey, I want to go to sleep for a few hours, wake me up at 7 a.m. or wake me up when you see some sensor issue or something over the network. And so we in this XG1, we have the ability for that MG12P module to be able to kind of take over. It can access the real-time clock chip, so the same one that Linux accesses. So you can actually say, yeah, hey, MG12P, shut me down, so it can actually control the main power supply to the Linux box, and then sleep, or it can stay awake monitoring the wireless network and things like that, and then wake up the main and reboot Linux when it needs to. So and that is it. There's a jumper configurable option to tell it we don't want to allow it to do that, but by default you can do that, and it's really neat, a really great way to get yourself into a mode where you can have a gateway that can sleep, for just maybe a couple hundred microamps. I think we didn't put in the capability to shut everything down, like all the quiescent currents of the supplies and the reverse polarity detection and things like that. There's a lot of beefiness that's built into that gives you, it's not super, super low sleep currents, but if you're running, otherwise you're burning half an amp, just idling on a gateway. So to be able to get down to, a couple hundred microamps is pretty good.
Yeah, it's a great, I thought that was a really interesting design aspect of the device. So, as I mentioned, the course was great that you did. A ton of information. You've given us a lot in this short episode of our podcast. As I mentioned, I encourage everybody to go and listen to the full one, as I put the link in the details. Would you guys mind sticking around? We'll do another episode and we'll cover the course you guys did and talk a little bit about, connecting the devices to the cloud and all the cloud infrastructure that's required.
Sounds good.
Sounds great.
All right. Well, that'll wrap up this episode. I thank all our listeners. I thank you, David and Donnie, for joining us today.
All right.
Absolutely.
Thanks, Kyle. We enjoyed it, and reach out to us anytime.
Sure. And to our listeners, thanks for listening and take care.